and welcome to Pale Blue Pod, the astronomy podcast for people who are overwhelmed by the universe but want to be its friend. I am your host, Dr. Moiya McTier, an astrophysicist, a folklorist, and a good friend to the universe. I'm recording today from my office here at Pale Blue Podiversity, and I'm expecting a guest who I think is also a friend to the universe. Brandon Grugle is an audio producer, composer, and head of productions at Multitude. He should be arriving any minute now. I believe his hot air balloon touched down about 10 minutes ago. Brandon, come on in.
It's me. I'm here.
How are you doing? What was the view like up there?
It was beautiful. I don't know how you secured this office space in Pale Blue Pod University. What was it? Pale Podiversity?
Pale Blue Podiversity.
Pale Blue Podiversity. I don't know how you got this like beautiful land, but you're like the Xavier School for gifted youngsters up here. It's
no,
beautiful.
We actually got it from Professor X when he moved to a bigger estate. Mm-hmm. So I'm glad it was recognizable.
Yeah.
Is there anything else you would want people to know about you?
I think this is one of the things that people maybe don't realize about me, that I'm a big old science nerd. I love Pale Blue Pod. I love astronomy. I don't know how serious I was, but I did for a hot second consider going back to school for something astronomy related, but then I realized I can't do math at all.
Yeah, and it's really unfair because they make you do a lot of math in the schooling, and then there's much less math in the actual doing of the astrophysics.
Well, that's just unfair. Yeah, I don't appreciate that.
It's false advertising.
But, so I'm excited to be here. Yeah, I agree. How much math did you actually have to do? Like, what was your final class that you had to do?
I went up to kind of intense multivariable calculus and linear algebra with all the matrices and stuff.
Yeah, that's the kind of stuff no thank you.
And then when I got to do my research, those concepts are important, but you never actually do it out by hand. Like, there are computer programs that do it for you.
Yeah, I'm good.
Yeah, fair enough. It's okay. We can talk about space, and it's like going to school for it.
Yeah, exactly. Oh, man, I went to the planetarium all the time, and I lived in New York, and I miss it. I need to start going to the planetarium here.
I'll second that.
Yeah.
The universe will third it.
Yeah.
Okay, well, I have some get-to-know-you questions so that I and the listeners can know you a bit better, dive into the core of who Brandon Grugle is as a person. Are you ready?
Yeah. I'm so ready.
Awesome. First question. When you think about space and how big the universe is, how does it make you feel?
It depends on the day, honestly. Like, most days it makes me feel good in the sense that it makes me feel like insignificant, and that's a good feeling for me. Because it makes everything feel, lots of people say this, but, puts everything in perspective. It makes it all feel silly.
Agreed.
Yeah. But also at the same time, I have always struggled with the idea of what is space expanding into? And the answer is nothing. And the answer is, what does that mean? And then how our silly little ape brains can comprehend all this stuff. So yeah, it's existential at night when I think about what it is, but only in a curiosity sense, not necessarily in a me specifically sense. But otherwise, it's good. It's good perspective for me, honestly.
Yeah, that's one of my favorite things about being close to the universe is the perspective it gives me.
Yeah.
Nice.
Yeah.
I'm glad you appreciate that too.
Yeah.
Do you also appreciate astrology? Do you feel like your sun sign fits who you are as a person?
Sun sign is the major one, right?
Yeah.
I don't know much about astrology, so I'm a Cancer, or at least I think I am. I don't know what the shifted ones are, but
at least you know they're shifted.
Yeah, I do, yeah. So I don't believe in any of the astrology stuff, genuinely, but they're fun to think about and to talk about and stuff. But from what I understand, I think Cancer fits me, but to be honest, I don't know much about. Do you know anything about Cancers?
I know that the constellation it's based on is one of the oldest constellations, thousands of years old. The ancient Babylonians had a crab constellation.
Oh, I didn't realize that. That's cool.
Yeah, that and Taurus.
Interesting. Yeah, I mean, I obviously, when I was growing up, I got a lot of teasing for being a crab and a Cancer, but...
Cancer's so mean. They'll just make fun of you for anything.
I think Cancer is supposed to be, sensitive, so that definitely tracked when I was growing up.
Okay. Nice. I'll try and learn a little bit more about it, maybe. But next question, getting a little bit back into the science. What law of nature would you change if you could, and how?
Oh, that's a great question.
Thank you.
Does it have to be a universal law, or can I just apply it specifically to when I want to?
It is a law that applies everywhere in the universe, but you can finesse it so that it's, like mass dependent or like localized in some other way. But it's not something that like only you have control over. Okay.
I like that. So if I could change gravity and somehow localize it, whether it's like, I don't know how I would localize it, but maybe it's only a small mass or something, but I want to fly.
Okay, then everyone can fly.
Yeah. But I think that's a more exciting world.
Or you could make it so that you can only fly in a particular place.
Oh, that's good. Yeah, yeah. Maybe it's like a trampoline theme park thing situation, but it's just for flying.
Amazing. So we will amend the laws of the universe such that let's add an extra element or something that is super anti-dense. And so it also gives you like anti-gravity. And let's put a bunch of that under this one town. You can discover it and you can build your proprietary sky zone on top of it.
Hell yeah. Do you know about the vortexes in Arizona, I think it is?
Excuse me? What?
I think it's Casadega maybe is the name of it. But there's a town in Arizona, maybe multiple towns, where they claim that there's like vortexes in which things like disobey the laws of physics. So like they have like a slanted house that like it looks like everything is sort of like slanted and should be going down towards the ground, but actually is going up. Optical illusions and stuff. But yeah, I like the idea that like maybe there's some vortexes underneath the earth that just change gravity. In very specific places.
That's the change. There you go.
Yay!
Yay! Everyone check out Brandon's anti-gravity zone. Next question. Imagine you're an astronaut and we're about to send you up into space, but because we're kind, we're putting you in charge of the playlist. So, especially as a musician, I'm curious, what song would you want to be playing during blastoff?
I mean, the easy answer is obviously David Bowie, Spaceman. But what's a better one? What's a more interesting one that is appropriate to me? Honestly, it probably would need to be something relaxing. Yeah, I don't know why I would want to be extra anxious on the ride up to space.
Right.
Phoebe Bridgers' album would like really calm me out.
Nice. I like that approach.
I don't know. Honestly, like, you'd probably pick stuff that would like remind you of your family and friends and your home and stuff. So, playlists that Lauren has made for me or songs that my siblings and I shared as kids and stuff. But now I'm thinking I could play a prank on my siblings by playing some of their shitty music they recorded. My brother was earnestly trying to be a singer for a long time as a young man. And so I have some of his tapes. Maybe I'll just blast that from the speaker so the whole world can hear it.
Yes, do that. Is there any way that's on Spotify? And could I add it to the playlist of Pale Blue Pod launch songs?
Ooh, I don't know if it's on Spotify, unfortunately. It might be on YouTube, but let me look around and I'll see if I can find something for you.
Awesome. Thank you. And final question to get us into the spooky theme of today's episode. What do you think is the scariest thing in space?
I think like for different reasons, right? So black holes are obviously scary in that if I got near one, it would suck.
Yes.
But for more like conceptually scary reasons, the fast radio bursts, I think that's what they're called. The ones that we don't really know what they are exactly yet.
Yeah.
We have some ideas, but like there are some that like we think they're periodic, but some that potentially like are so on such a long time scale that they haven't repeated yet. And that's terrifying. Are those aliens? Is that a ship? What is that?
It's a great question, Brandon. I wish I had an answer for you. Yeah, FRBs, fast radio bursts, and like the other weird transients, like all the bursts, the gamma ray bursts, supernova. Yeah,
I want to see
one.
I would like to see a supernova, though. I mean, I don't want it too close, but I want to see it.
Right. I think simulations have shown that if a supernova goes off within about like 50 light years of us, it would ruin our food chain because it would kill the like phytoplankton in the ocean. And also it would probably ionize our atmosphere so that we couldn't really breathe anymore necessarily.
Can I change my answer to everything in the universe is scary? Everything wants to kill us.
Yes, you can. Final answer. But no, I think that gets us in the mood. I usually don't like to be scary, spooky on Pale Blue Pod because this is a cozy podcast.
Yeah.
But it's spooky season. It is October now. It's officially spooky season. I don't care what anyone says. Honestly, I started celebrating spooky season weeks ago.
Exactly.
So today, we're going to be picking out the scariest exoplanet that there is, based on whatever Brandon is most afraid of.
Hell yeah, I love it.
Brandon, do you have any fears that you think would be relevant today?
Good question. I don't have any like true phobias, I don't think, but I have like a minor thing about claustrophobia. So I think about living on Mars in like the lava tubes or something like that, and I'm like, no, thank you. I would not do that.
I wouldn't either. Yeah, good survival instincts, Brandon.
Thank you.
All right. Well, I first want to say that we know about a lot of exoplanets out there. I did a whole episode on how to find exoplanets. It was episode 20, out 2.5 years ago. So in case it's been a long time for you, there are a few different ways we can find exoplanets. My favorite is transit photometry. Are you familiar?
Yes, because I've listened to episode 20.
So would you like to, could you explain it?
Yeah, roughly, and please correct me if I'm wrong, but the idea is that as bodies, some exoplanet or whatever it is, move in front of some other piece of light, some other something that we can detect, it will take a dip in the, not radiometry, but the light photography, whatever you call that. Photometry, thank you. And we can sort of see that dip over time. And if it's periodic, if it's regular, we can sort of assume that something's rotating the star or whatever it is. But also it has to be on the same plane as us. So that's a limit.
Yes. Gold star. Perfect.
Yeah, hell yeah.
That's my favorite. That's what most of my research was in when I was studying exoplanets. The next most successful method is radial velocity. Do you want to take a crack at that?
No, I don't know that one.
Okay, radial velocity, or RVs, is when the gravity of the planet tugs a little bit on its star and makes the star wobble. And we can study how much that star is moving from its central location and estimate or calculate how massive the planet must be.
Okay. Is the planet not? I guess Planet 9 at this point. Planet, what do they call it now? Planet X? Whatever the like.
Planet X.
Yeah.
Yeah, we're still looking for it.
Is that because that's gravity based, right? Like that's why we think it is.
That's based on we can really precisely measure how long it takes planets to go around the sun. And when there's any sort of deviation, we expect that that's because some gravitational influence is happening where we can't see it. This is how we discovered definitely Neptune, maybe Uranus.
Oh, okay.
Because something was tugging on the inner planets. And we think that something is like tugging a little bit on Pluto, but it's hard to tell and even harder to see.
Yeah. Interesting. Cool. I love it.
But it's not impossible to see planets because a handful of planets have been discovered through direct imaging, which is exactly what it sounds like.
Yeah.
But it's really hard to do. The planet needs to be really big and far away from its star, so usually like Jupiter-type planets. And then there's microlensing, gravitational lensing, where you can see a planet because it passes in front of something and its gravity bends the background image's light to it, or something massive passes in front of the planet and bends the planet towards us. Like it's really,
that's cool.
You just have to be really lucky that things line up.
Yeah, that's cool. I didn't realize that we had done any actual direct imaging of exoplanets.
Yeah, maybe something like 10 planets have been directly imaged, but cool. It's not a lot. So as of the day we're recording, September 16th, there are 5,989 confirmed exoplanets.
Hell yeah. How many do we assume, or how many are estimated to be out there, do we think?
hundreds of billions in our galaxy alone.
Jeez.
We think on average there are like a couple planets per star, and there are more than 100 billion stars in the Milky Way.
Cool.
Yeah. So we're
really neat.
basically just examining a drop in the bucket at this point. But I encourage people to go to the NASA Exoplanet Archive because you can play with data. It's a really easy way, I think, to get introduced to data because they'll plot it all for you and you can just see how different things relate to each other. Like you can plot the planet's radius, like its size versus its mass, and see what the relationships are like.
That's really cool. I didn't know that. That's awesome.
Yeah, it's a fun tool.
NASA, good organization.
Yeah. Let's give NASA some money.
Yeah, I think so. Oh, I didn't even realize I was wearing my NASA shirt today.
So perfect, so appropriate. More than half of the planets that we've found are between the sizes of Earth and Neptune. We call these super Earths or mini Neptunes. And that doesn't necessarily mean that those are the most common types of planets. It's just really easy to see them.
Right. Is that because they're big enough to see via the transit method?
Yeah, they're big enough and close enough to their stars.
Got it.
The transit method especially works for bigger planets that are close to their stars because the more of the star's light proportionally that the planet blocks, the easier it will be for us to detect it.
That makes sense. And do we assume that these are similar in like composition to Earth and Neptune then because of their size, or could it be anything?
Well, that's a particularly tricky zone, the transition zone between rocky planets and gas planets.
Right.
And the limit that we use as a rule of thumb is about 1.6 times the size of Earth. Typically, things that are bigger than that are not rocky anymore. And so they wouldn't have similar compositions because once you get above that, it's more gaseous.
Got it. Cool.
But we're trying to figure out what is that threshold, like what is the transition space? Does it have more to do with the distance from the star or the whatever the chemical composition of the disk is when the planets are forming? Like that's an active area of research, and the distance from the star does matter a lot. Most of the planets we've found are much closer to their stars than Earth is to the sun.
Interesting.
But again, that's just because they're easier.
Yeah. Oh, sure. Yeah, that makes sense.
Yeah, there are probably, hundreds of planets in systems that we have studied that just orbit too far away for us to detect. And
are those more likely to be in like the habitable zone? So does that mean that we're not going to be able to find any cool alien friends because they're not big enough?
We can absolutely see planets in the habitable zone. And I think one of the planets maybe that we're going to discuss today is the right distance to be the right distance away from its star to be in the habitable zone. But also not all stars are like our sun. So for smaller stars, the habitable zone is much closer. And around like M dwarf stars, the red type stars, we do see many planets that are technically in their habitable zone.
Cool.
Yes. Okay, I have the scary planets list here for you. I have 8 of them, and I'm going to describe them one at a time. Your job is to tell me, so I guess starting at the second one, is this planet scarier or less scary than the planet before? And so it's going to be like single elimination bracket style.
Love it. Cool. Smart.
You do get one comeback later.
Okay.
And you do get one honorable mention.
Okay, hell yeah.
Yeah, because I know that I'm bad at choosing, so I wouldn't have to make all these decisions. But are you ready for Planet 1?
I am so excited. Let's go.
Okay, great. These are some extreme exoplanets. We're starting off with the hottest exoplanet that has ever been discovered. It's called Kelt 9b. It was discovered in 2017 by the Kilodegree Extremely Little Telescope, or KELT.
It's so little.
It's so little.
It fits in your pocket.
I love the way we name things sometimes. KELT scans the sky for transiting planets. So it is a transit survey. And Kelt 9 is the star. Kelt 9b is the planet that is closest to its star. It's also called HD 195689, which tells you its coordinates because these stars have multiple names based on whatever catalog you happen to be looking at.
Okay. Do we ever give them, I know I'm sure the researchers do, but do we ever give them like actual nicknames, or is it just like Oh, we
Yes.
do. Okay, cool.
But only for like the weird stars. There's one star that when I was in grad school was having these really weird spikes of light. Like it would get brighter and dimmer rapidly. And it was nicknamed Tabby's star or Boyagian star because Tabby Boyagian was the astronomer who like really studied it. That's usually how it works.
Got it. That's a cool name, though.
And so if you ever see a star and it has a bunch of like AKAs after it, it's because we have studied it in many catalogs.
And they have a really fire mixtape that they're coming out with next.
Exactly. They're in the garage working up a storm. The star is 17,000 degrees Fahrenheit. It's about 2.5 times the mass of the sun. So it's bigger and brighter and hotter. It's actually on the verge of being like between an A and a B type star, it's the second and third most massive types of stars. And we usually don't see planets around them because stars that massive don't live very long. And it takes millions of years to make a planet. So I think this was the first planet that we saw around a star that massive.
Oh, cool. That makes it actually kind of nice. Although it's a hellscape, but...
It is a hellscape, yeah. I do need to tell you more about the hellscape of it. But I want to talk more about the star first.
Okay.
It's really young. This is why we can see that it still has planets. It's only 300 million years old. Oh, and it's actually the 5th A-type star known to host transiting giant planet.
Oh, cool.
Yes. The planet itself is 670 light years away from Earth, so not that far, actually. And it is 3 times the mass of Jupiter.
Wow.
It's big.
Wow.
Yes.
Okay.
And it is close to its star, which is already so hot. It's close enough to its star that it orbits every day and a half.
Whoa. A year is a day and a half?
A year is a day and a half. Yeah. Keep in mind, Mercury orbits the sun every 88 days. So just imagine how close this Jupiter-sized planet. It's basically touching its star.
Do you think at what point, I mean, I guess maybe the answer is never, but at what point, if you were on the surface of a planet like that, would you feel like you're whipping around the sun?
Like when you first land on it, yeah. And then once you're not accelerating anymore, you wouldn't feel the force.
Yeah.
Yeah, but it would be a difficult, step off your rocket ship.
Yeah.
So it orbits really close to its star, and because it's so close, it's tidally locked. Do you know this term?
I've never, honestly... That's the one where I hear it. I'm like, oh, yeah, that makes sense. But
makes sense.
I'm not going to even try to. You explain it.
Okay, cool. Our moon is tidally locked to the Earth, and many close-in planets are tidally locked to their stars. It means that one side of the body, either the moon or the planet, is constantly facing the thing that it's orbiting. So that means that its year is the same length as its day.
Oh, okay, cool. Yeah, that makes sense.
It basically does one rotation as it does one orbit.
Got it. So why is it, I mean, obviously it has to do with the tides, but why are we named after the tides as opposed to facially locked or something?
Because tidal forces is the physics term for exchanging gravitational energy.
So it's not like literally water tides. It's like, I see it.
Yeah, gravitational tides.
Got it. I never understood that. Thank you.
Yeah, and it is the energetically favorable state, just like the most efficient type of rotation that the planet can do. And that means that there is a day side and a night side. And the day side has a temperature of 7,800 degrees. It is the same as some types of K stars. Like there are many, many types of stars that are cooler than this planet. The high temperatures and the extreme ultraviolet radiation that you get from the star excite the molecules in the planet's atmosphere to break apart. So the planet is losing its atmosphere fast, and scientists estimate that in about 200 million years, it will not be able to exist anymore. And also the star will stop fusing hydrogen, so it will puff up into its next stage. So this system doesn't have long.
Oh no. That kind of makes me sad for it, honestly.
Yeah, it's very sad. It's a sad, hot hellscape. Let's compare that to the coldest planet, and then you have to tell me which one is scarier.
Okay.
Ogle 2005
Ogle?
hyphen OGL.
Okay.
Ogle 2005-BLG-390LB.
Mm-hmm.
Official name, was confirmed in 2006 with the Danish telescope Ogle, part of the Ogle program. Ogle stands for Optical Gravitational Lensing Experiment, so they were looking for those micro-lensing events that I told you about. And there are many observatories that are a part of this Ogle mission, and so the Danish telescope in Chile is operated by the European Space Observatory. The star itself is 20% the mass of the sun. It's really dim. It's only about 3,000 degrees Fahrenheit. So the star is really dim, and the planet orbits really far away. It orbits every 10 years.
Whoa. Mm-hmm. So I'll be younger on this planet.
Yes.
I'm only 3.4.
Yeah, exactly. Well, your genes won't know that, but yes, your birthday will come less often, and it orbits somewhere between like Mars and Jupiter in our solar system. And if it doesn't have any internal heating mechanisms, and we're not sure if it does, its temperature would only be 50 degrees above absolute zero.
That's really cold.
It is so cold that astronomers call it Hoth.
Oh, that's good.
Would you like? I don't know what Hoth is. Can you tell the listeners what Hoth is?
It's the Star Wars planet in the second or the fifth movie, however you want to categorize it. The second one to release. It's the one with tauntauns, and where Han cuts a tauntaun in half, and Luke goes inside to stay warm.
Oh,
because he gets trapped outside, and when at night it gets really, really cold, and so he had to warm up, so he got shoved in there. But it's the ice planet, yeah.
Awesome. Well, this planet is like that all the time. Is that scarier or less scary than the hottest planet?
I hate being hot.
Okay.
I was also raised in a Christian household, so this feels like some sort of mystical hell. The first one does, and the fact that it's going to like disintegrate into the sun over time relatively quickly also makes it even more terrifying if you were to be on that specific hell planet. So I think hell planet is going to take the cake here for this first round.
Okay, Kelt 9b is still the scariest.
Yes.
Then let's compare that to WASP 12b. This is the planet that is being ripped apart by its star actively. It was discovered in 2008 by the WASP mission, which stands for the Wide Angle Search for Planets. It's a transiting planet mission, but it has a really wide field of view, so it can see much of the sky at once.
Cool.
The planet is 2 Jupiters big and 1.5 Jupiters heavy, which actually makes it pretty low density. And that is important for its relationship with its star. Low density means there's like less gravitational energy binding it together. It orbits only 2.2 million miles away from its star, and the gravity relationship between them makes the planet egg-shaped. It is not spherical. It's massive enough to be spherical, but its star is distorting it. And we think that in about 3 million years, the planet is going to spiral into its star.
Cool.
Yeah. But it does have water in its atmosphere.
Hey!
According to the Hubble Space Telescope. However, its temperature is so high that you would probably be boiled alive in the water vapor.
I'm going to imagine that there are little creatures in there that live in the water atmosphere that fly. And as the planet gets torn apart, that's just more real estate for them. You know? It's like finding new little island chains.
So is this planet less scary because it's more egalitarian?
I think this one is less scary than Hellscape. It's got water, even though it's super hot water, and I like water personally. I'm a big fan.
Yeah.
And I can imagine, little real estate tycoon microbes being like, oh yeah, now we got new real estate to sell. So that makes it cute.
Yes, if the robber barons are microbial, they're adorable.
I wish our robber barons were microbial.
I know. Me too. I also like water, so that makes sense. And I think on that note, everyone take a water break.
Take a water break. Do it.
Hey friends, it's me. Brandon took that hot air balloon back out to map the acoustics of the Podiversity campus, but it's okay. I gave him my sonic topographer, so it shouldn't take him that long. But I do still have a few minutes to share some messages with you. And the first is a thank you to all of my patrons. As an independent podcaster, it would be so much harder to make Pale Blue Pod without your support, so thank you so much. And I want to give a special shout out and a huge thank you to my Sun Like Stars, Scott Reynolds, Tom T, Nicole Bartlett, Ashley Shambo, and Mark Mahoney. You're a beautiful club. You are golden with the perfect mass. Thank you all so much. If you would like to join this awesome group of people, hear your name on the show, make it onto my Patreon star chart, and get research notes for most episodes, you can do that by joining my Patreon at patreon.com/palebluepod for $5 a month. And brighter tiers, like my Sun Like Stars, get access to Pale Blue Pod at night, where I read bedtime stories in what I hope is a calm, soothing voice. But no matter what type of support you can give Pale Blue Pod, whether it's joining the Patreon or sharing a link to an episode with a friend, I appreciate you so much just for being part of the Pale Blue Pod universe. So thank you. My next message is a podcast recommendation, another show in the Multitude Collective, and it's called Wow If True. This is your one-stop internet culture shop explaining how what's happening online shapes the real world. And the hosts are the internet experts and real-life besties to unravel it all, tech culture journalist Amanda Silberling and science fiction author / attorney Isabel J. Kim, Esquire, lead the show. More importantly, this is the only podcast that will mention Neopets and horizontal mergers in the same episode. They actually did that. They also just did an episode about age verification on the internet, and that's super helpful if you've been trying to follow along with that messy facet of our chaotic present, as I have been. But the internet moves so fast, and Wow If True is there to keep us all up to date. So check out Wow If True wherever on the internet you find your podcasts. New episodes come out every other Wednesday. My personal plug for the week, as it has been for the last 7 weeks, is about That's a Lot. But I'm here to tell you that all of the episodes, all 14 of That's a Lot, are now out. So you can watch them all on Instagram, TikTok, and YouTube. And I would really appreciate it if you would please go check them out. It would take you less than half an hour to watch the entire season. All 14 episodes are 2 minutes or less. So check out That's a Lot if you want to laugh about the state of the world we're in right now. Okay, Brandon is back, and apparently he found a natural whisper corner on the quad. You know, one of those places where you can speak in one location and then your voice gets carried somewhere else. So I'm going to be checking that out later. But for now, let's get back to these scary exoplanets. We'll come back and compare still Kelt 9b to the darkest planet that exists. This is Trace 2b. It was discovered in 2006 by the Transatlantic Exoplanet Survey, or TRACE, run on the Palomar Telescope in California and the Lowell Observatory in Arizona. So they're working together. And that's how it was discovered, but it was confirmed by the Keck Telescope in Hawaii. And I like telling that whole story because it shows how collaborative science in general is, but also like exoplanet science. Like we don't just see a signal and say, oh, there's a planet. Like we are very careful about confirming it with multiple telescopes in different locations.
Yeah, that's great. I love that. I also astronomers do the thing where they do like a backronym, like politicians do, where they're like, I want to call this one Trace. So let's,
Yes. Absolutely. I think most of our acronyms are backronyms.
I don't know if because it's Danish, I don't know if it was this, but Ogle or what was it? OGL?
OGLE. It's the optical gravitational lensing experiment.
Yeah. I mean, you add an extra O on that, it's just ogle. And that just is funny. Like you're ogling the universe.
Yeah, there are some good ones. I think I did a whole acronym episode, and there were too many to cover in just that one, so maybe I'll have to do a part 2.
Yeah.
So Trace 2b orbits a star that is pretty much like the sun, like very similar mass, very similar temperature. And the planet itself is a little bit more massive than Jupiter. It orbits very close to its star, and it orbits every 2.5 days.
Whoa.
But the reason it's called the darkest planet isn't because very little light shines on it. It is because most of that light gets absorbed and not reflected. apparently only 2% of light that it receives gets reflected back out into space, and everything else it just absorbs, like that deepest color black.
Like the Vanta black.
Like the Vanta black, yeah. And when I was researching this, I didn't realize it, but apparently my grad school advisor was the person to write this paper on how dark it was.
Oh, that's so cool.
I know. He's had such an interesting career. So my advisor was David Kipping, and in 2011, he wrote this paper with David Spergel because there is an abundance of Davids in astronomy.
Many Davids.
and they, using transits, were able to figure out how much light it emits.
That's cool. So if you were in the atmosphere, though, if you were like on the planet, let's assume it's rocky, it's probably not, but like you were standing there, would there be light in the planet? Like, would it be able to get through?
Yes, light gets through to you, but here on Earth, we experience the direct light of the sun. When you're standing in it, you get apricity. We have like a special name for heat when you're standing directly in the sun. But there's also so much other light and heat that gets reflected off of objects around you. And on this planet, you wouldn't have that. I almost want to imagine it as if like there is light coming down on you, but you still can't see everything around you. Like everything around you is still in shadow, even though light is shining down.
That's really cool and also pretty spooky.
Yeah. Yeah, that's why it's on the list. So how does it compare?
Ooh. I think, okay, so hellscape is scary because it's hellscape. And fire is bad, and that's a horrible way to live and die. But in terms of spooky factor, I think this takes it. Like, this is way spookier.
Yeah.
That's like another dimension where you like go and like light works differently, you know? I think it's very cool. Yeah.
That's what I thought too. Like, this would be, I think, such a cool setting for a horror movie because it's like, why can I see everything but nothing?
Yeah, exactly. And like, you know, in horror movies or in your real life, you like see something out of the corner of your eye or see a shadow, but it's like, what does that even mean on this planet? You see a shadow? I don't know. Everything's shadow. Nothing's shadow. What does it mean?
Right. And imagine like they would have different words for different types of shadow because there's daytime shadow and nighttime shadow.
Yeah,
like imagine the pure darkness when it is actually nighttime on this planet.
Yeah. That's wild.
Okay. So this is moving on. This is advancing. Excellent. Okay.
I'm also curious how sound would work on that planet because sound is obviously affected minutely, but some by the ability for objects to reflect the temperature, the everything like that involves sound. So I'm wondering what it would sound like. It would sound slightly distorted too.
Yeah, I don't think we know what the composition of the planet is. Like maybe it has some cool mineral on its surface that like is dampening of all types of waves.
Who knows?
Who knows? But we can imagine. Okay, so the darkest planet is moving on, and we now have to compare it to the first Earth-sized rogue planet that was ever discovered. Have you heard of rogue planets?
Yes, those are planets that don't orbit a star, correct?
Yes. Yeah. And
great.
There are tens of thousands of them out, we think, in our galaxy. And they most likely formed around stars, like 99.9% sure they formed around stars and then got ejected from their system through some gravitational interaction. And when we are lucky enough that one of them passes either in front of or behind some massive object, we can detect them with gravitational lensing.
That's cool. Also, what did they do? What did they do to piss off their star?
Well, what did the star do to piss them off? Might be the better question.
That's true.
The stars, they're so hot-headed. They can really get on people's nerves.
Yeah.
So it's a gravitational lensing event. It was discovered through the OGLE mission. So we're back at OGLE. This one is called OGLE 2016-BLG-1928.
Wonderful. BLG stands for Big Little Guy. Love it.
Little guy. We can call it little guy. The signal was first received in 2016, but it was then put in this like archive of data waiting for a scientist to come along and analyze it. So it wasn't found and confirmed until 2020. Wow. And it was announced on October 29th. So it's like a Halloween planet.
Yeah, love it.
And it is Earth-sized or smaller. It's really hard to get a firm grip on it because it's like we only observed it once, and there's not repeated data that we can use to minimize the noise from the signal. So we know that it's Earth-sized. It doesn't orbit any star, so like that, there's no information about that. But if it doesn't have any sources of internal heating, it's probably pretty cold.
Right.
But it very well might.
Yeah.
You know, any sort of volcanic activity, any sort of high amounts of radioactive elements in its core could all provide heat that, you know, makes a star unnecessary.
Sure.
But it's alone. I think that's the factor.
That's what I was going to... So if it's a rogue planet, is it captured by something else necessarily, or is it like hurtling through space, being captured and being tugged and moved around as it goes through space? Or both, maybe?
More like the latter, but I can imagine over its billions of years that it might, you know, get brought into a star and then ejected again. Like they're wanderers.
Okay, cool. So yeah. So if you were chilling on this planet, you would have to deal with a new fresh hell every day as you hurtle through the universe with
more
extreme...
like every several thousand years. Things move slowly, but yeah.
That's actually really interesting because, like, I mean, I know it's not really enough time to evolve, but let's say there is a species that already is extant, and like every 1,000 years it sort of has to reinvent itself in order to exist on that planet. That's really cool.
Yeah, like the Broken Earth trilogy, but on level 11.
Yeah. I think this is more like sad or like melancholy than spooky. So I think I'm going to stick with Shadow Planet, with Vanta Planet. But I like this planet. Like I want it to come close to us so we can, you know, share our star. Come hang out with us, you know?
Yeah. Our house is your house too.
Yeah.
Ogle 2016 BLG 1928.
You're just a big little guy.
Okay, great. Okay, so it's maybe we'll keep that in the back pocket for an honorable mention or something.
Yeah. Love it.
Okay. Next, we're comparing that to the planet with the most eccentric orbit, so like the least circular shaped orbit. This is HR 5183b, the closest planet to its star, discovered in 2019 with the radial velocity method, so the one where you're examining the wobble of the star.
Cool.
Multiple observatories saw it over 22 years. They had to combine data from that long because the planet's orbit is quite wide and very strangely shaped. Based on those 22 years of data, they've determined that the planet is 3 times the mass of Jupiter, and it takes about 75 years to orbit its star. But its eccentricity is 0.84, so it's like 84% of on the way to being not a circle.
That's almost 100.
It's almost 100. It's almost 100% not a circle. In reality, its orbit swings between Mars's distance from the sun and Neptune's distance from the sun.
Whoa, that's cool.
Yeah, very cool. But it experiences these huge temperature swings over the course of its orbit. And its speed changes quickly because when you're closer to the star, you're moving much faster than when you're far away from the star. So like you were talking about earlier, like if you were to transport yourself to that planet zipping around its star very fast, how would you feel? If the acceleration is constant, you wouldn't feel much, but acceleration isn't constant on this planet.
That's true. And it takes how long to orbit the sun?
About 75 years. And most of that will be spent out towards the orbit of Neptune.
Interesting. So for like, you know, I'm making this up, but like 60 years, it's like a relatively chill time. And then for 15 years or 20 years, it's like, oh, this sucks so much.
Except the chill time is also like cold and dead and there's
Literally
no energy to keep any crops going. And so that busy time that sucks so much is also when you have to do all of your preparing for the hard winter times ahead.
Grow enough food for 60 years. Oh man. Scary. I mean, that is pretty scary because you're like, the uncertainty is pretty scary, you know?
Mm-hmm. And I imagine society would be, I think astrology would matter a lot more on that planet. I think that's the way I want to put it. Like here, there is very little difference in the resources you get if you're born in January versus like July or something. That wasn't always the case, but like now it's pretty much evened out. On this planet, if you're born during the time of plenty, but the time of rush, like that, I think gives you a very different life than if you're born during the slow time of, famine, but togetherness.
Yeah. Now I could also consider, the, I think Danish or Scandinavian at least thing of like hygge, the thing in winter when you like are cozy. Now imagine that, but for 60 years. That's nice.
That's nice. Yeah.
I think I'm going to stick with Shadow Planet for now.
Okay.
Because it's just spooky.
Do you want to choose to come back to it? You do get one come back to it.
Oh, yeah. Yeah, let's do this or come back to it.
Okay, we'll come back to it. Cool.
Yeah.
Then the next planet, still comparing to the darkest planet, is the most extremely tidally locked planet. It's called Upsilon Andromedae B, and I did kind of just want to include it for the name. Not going to lie.
Upsilon.
Upsilon. It was discovered in 1997. It was one of the first. So that's why it doesn't have one of these mission names, because it's named after like where it was found. It was discovered with radial velocities at California's Lick Observatory, and it orbits around a binary pair of stars. So it has two stars.
Tatooine!
Yeah, like Tatooine, except does Tatooine orbit both of the stars, like both stars in the center?
It's a good question. I don't know if George Lucas cared enough to write that.
Okay. Well, this planet orbits just one of the stars, and then the other star is like, also in the system. But one of the stars, the one that it orbits, is an F-type star, much bigger and brighter than our sun. And the other one is much smaller. It's an M-dwarf star. This planet, Upsilon Andromedae, orbits the bigger star every 5 days. So it's really close. And it's tidally locked. Most of the hot Jupiters that we discover are tidally locked. But there's something about this planet's atmosphere that really exaggerates the temperature difference between the day and night side on this planet. The day side reaches temperatures of 1,400 degrees Celsius. I didn't do the unit conversion, I'm sorry. And the night side reaches minus 200 degrees Celsius.
That's bad.
It's a 1,600 degree temperature swing. I think in Fahrenheit it would be even greater, probably closer to like 18, maybe 2,000 degree swing. But like we call it the terminator, the zone between the day and night side, would be so stormy. Like that would be like the atmosphere having to exchange energy from the day to the night side at that zone would give you storms galore. And that's really the only place where you could live. Like you can't live on the day side. It's too hot. You can't live on the night side. It's way too cold and there are no resources. The only livable place is the Terminator, but it's going to be like the Pacific Rim. Is that
the movie
stormy?
or the real life thing?
The place. Bad.
Interesting. Yeah, I was going to ask that because I was like, in my head, I was like, yeah, you could live in the middle, and then what would that be like temperature wise? But yeah, thinking about the storms that would exist there. Have you seen Mad Max?
Is that a desert?
It's a desert, but I forget if it's Fury Road or the most recent one, but there's like a giant dust storm that they like drive through. I'm just imagining just like this wall of storms that you have to live through. That's pretty scary.
Yeah.
Oh, that one's tough. Does that beat Shadow Planet? Oh, I don't know. How do you feel when rain and lightning storms come through?
See, I love rain. I love a lightning storm. I decided to spend my life in the Northeast because I need the nexus of public transit and lightning storms. So
that's good.
I think, if the infrastructure was there to handle it, I might enjoy living in the Terminator, but I just don't know how you could possibly catch a break for long enough to develop that infrastructure.
Right, yeah. Oh, this one might be the honorable mention for me, actually, now I'm thinking about it, because I really like this one. It is scary, and like learning to live on that Terminator would be awful, and like the shifting climate or the shifting environment in terms of storms, how they move every second would be awful. So I think that might be my honorable mention. I like that one.
Mm-hmm. Yeah. And the name, I think, is worthy of an honorable mention.
Yeah. Did you say there was a Lick telescope?
Yes. Yes, I did. Spelled L-I-C-K.
Okay, so that one wasn't an acronym. That was just
I think it's named after a person.
Oh, okay.
Nope, this is the telescope everyone comes to lick.
Good luck.
Oh, well, okay. New bucket list item added, actually. Thanks.
Lick
Thanks
the
for
lick.
that. Okay, for the final planet, we're still comparing to the dark planet.
Mm-hmm.
This one is called HD 189773b. It is the planet where glass rains sideways.
I was going to ask if this was going to be one of the ones you were going to choose. Hell yeah.
Yeah, you know your planets well. You know which ones had to be on the list. It was discovered in 2005 as part of a French mission called the Elodie Metallicity Biased Search for Transiting Hot Jupiter. So it is specifically looking for big planets very close to their stars. Mm-hmm. The star it orbits is a little bit less massive than the sun, but still pretty bright and hot. The planet orbits every 2.2 days and is a little bit bigger than Jupiter. It has a thick, like 3 C's, thick, energetic atmosphere, and the wind gusts can exceed 5,000 miles per hour.
That's so strong.
So strong. It's like literally like more than 10 times as fast as winds get here on Earth. It has really hot temperatures because it's so close to its star. And we learned in 2013 through the Hubble Space Telescope that there are a lot of silicate particles in its atmosphere. They actually make the planet visibly look blue to our eyes.
Whoa,
so it's pretty.
cool.
But there are basically shards of glass just falling in the atmosphere, and the high wind speeds will shoot them sideways.
Yeah, that sucks.
It does.
Now, when you say silica, what was the temperature on the planet? Sorry, did you say?
I didn't say, but if I had to estimate,
It's a hot Jupiter, you said, right?
it's a hot Jupiter. So,
Okay.
like many, many hundreds of degrees.
Interesting.
I don't think it's molten. There was a planet that had molten iron that would rain down because it was a little bit hotter, but I think the wind makes it scary, and glass is scary, and it's pretty, which means it's eerie, because pretty plus scary is eerie.
Eerie, yeah, that's true. Oh, man. I can imagine going to this planet and being like, oh, wow, look how pretty this is. And then immediately being atomized by tiny, tiny shards of glass.
Yes.
That's fun. But I, leave a beautiful corpse, I guess.
Mm-hmm. You become a disco ball.
Yeah.
Because the wind will pick you up and just suspend you in the sky.
Oh, man, I can't choose co-winners, though. Could you imagine this happening in the dark?
Terrifying.
Oh, I don't know. What's scarier to you, this dark planet or the glass planet? If you had to pick.
See, to me, anything that is like closer to existential terror is going to be scarier than just like physical terror.
Yeah. I agree, because there's so much your imagination could do in the dark planet to really mess you up.
And that is what's going to raise my heart rate the most. Like if I step off on the glass wind planet, it's going to suck, but I'm going to know exactly why it sucks.
That's true. It is very eerie, though. I like that description of eerie. Mm-hmm. I think I'm going to have to stick with my answers, though. I think Shadow Planet, Vanta Black Planet is the spookiest, and then honorable mention to the Storm Planet because sort of the same reasons, like the amount of shifting terrain, shifting environment can sort of wreak havoc on your psyche as you try to live into it.
For sure.
But this glass planet is cool.
Do you want to come back to the extreme eccentricity planet?
Oh yeah, I think I'm still going to have to stick with my answers though. But I think I really like that one and this glass planet. I think that they all get second honorable mentions.
Okay. Really, this entire list is an honorable mentions list because out of nearly 6,000 confirmed planets, these are the 8 that I think were spookiest.
Yeah. Are there ones that are even like more dangerous, I guess, or is flinging glass at 5,000 miles an hour? Which, by the way, a Category 5 hurricane I just looked up is 150 miles an hour or something. So yeah, or is that the most like deadly that you can imagine? These
were the most extreme that I could find. There are others like that molten iron one, but it's all kind of variations on the same theme. Like this planet is really, really hot and it has high pressures or high winds or something.
Love it.
Yeah.
Cool.
Hopefully this episode makes people appreciate how not scary Earth is when we take care of it. And don't go to any of these planets.
As we say at the end of every episode, don't visit these planets.
Yes. Brandon, thank you so much for choosing for me because I didn't want to have to make this decision. I would love for you to brag about yourself and tell the listeners what you got going on and where they can find you online.
Yeah, I am purposefully offline most of the time these days, so don't look for me. But if you want to check me out, check out my show that I work with 3 other collaborators on called Join the Party, which is a actual play D&D podcast. This is really fun. And
one of my faves.
Yeah, and check out every other show on Multitude. I have a hand in all of them, and they're all super, super fun and great, and I'm very proud of them, and the hosts are cool.
Yay! Yes, and Brandon is one of the few people who's ever edited one of my podcasts. I trust him, and I admire his skills.
Thank you.
Okay, I think on that note... Oh, no. Brandon, do you have Halloween plans? Do you have a costume?
Ooh, I don't do costumes because I am a little anxious boy who is always too anxious to do costumes.
Very Cancer of you.
Yes, exactly. But I've definitely gotten more into Halloween as an adult, and I am starting to expand my spooky season out. So now all of October is spooky season for sure. There will be candy involved. There will be some sort of... it's called a candy apple. It's like... cider and a brown ale, and you mix it together, and it's really tasty.
Ooh, but not your grandpa's candy apple then.
Not your granddad's candy apple, yeah. But most importantly, I've convinced Lauren this season to watch a bunch of spooky horror movies and scary movies with me. So we're going to do that this season because we haven't seen a lot, but we're going to go through it together.
Yay! Oh, I hope you have the best time. This is my favorite time of year, so please enjoy your spooky season.
Yeah.
And listeners, no matter how spooky you're planning on getting, you are space. Bye. Pale Blue Pod is hosted by me, Dr. Moiya McTier, a.k.a. the universe's bestie. I created the show with original co-host Corinne Caputo, a comedienne extraordinaire, and help from the Multitude Productions team. Our theme music is by Evan Johnston, and our cover art is by Shay McMullen, and our audio editing is handled by the incomparable Misha Stanton. I am Go Astro Mo everywhere online, and you can stay in touch with the show and the universe by following Pale Blue Pod on Instagram or checking out our website, palebluepod.com. We are a member of Multitude, an independent podcast collective and production studio. So if you like Pale Blue Pod, you will love the other shows that live at multitude.productions. And if you want a shout out on the show and research notes for every episode, you can join our community over at patreon.com/palebluepod for just about $1 per episode. Thank you so much for listening to Pale Blue Pod. I'll be back next week. Bye.